Good evening, students. I am teaching CBSE syllabus chapter-1, first chapter real numbers. In previous videos, I am explaining example 8, example 1, 2, 3, 4, 5, 6, 7, 8. Okay, here example 9. Show that any positive odd integer is of the form 6n plus 1 or 6n plus 3 or 6n plus 5, and any positive even integer is in the form of 6m or 6n plus 2 or 6m plus 4, where m is some integer. How we can prove? By using Euclid division lemma. So here, which integer we don't know that. Let us take a is any positive integer. Here what they are asking, that any positive odd integer is in the form of 6n plus 1, 6n plus 3, 6n plus 5. That means these numbers are divided by 6. Okay, the remainder is 1, 3, 5. Okay, we can show that this number is divided by 6. We can show that these are odd integer and these are even integers. Okay, odd integer means what? A number which is multiples of 2, the remainder is 1. Even integer means what? The number which is multiples of 2. Okay, so here the divisor is 6. How we can prove? By using Euclid division lemma. By using Euclid division lemma. 10 is quotient is m. Here which integer would you know that? Let us say that is m. Remainder is r. So by using Euclid division lemma, a is equal b into q plus r. Here a is equal b. The divisor is 6. Q is m. Remainder is r. So what are the condition of remainder? It is less than or equal. It is the remainder is greater than or equal 0 and less than the divisor. So here what is the divisor here? 6. That is 0 less than or equal less than 6. So what are the remainder values here? Remainder is equal 0, 1, 2, 3, 4, 5. Okay, that means the remainder is greater than or equal 0 and less than the 6. Okay, so here what are the values? 0, 1, 2, 3, 4, 5. Next, here how many cases are there? 1, 2, 3, 4, 5, 6. Okay, here case 1. Case 1. If r is equal to 0, then a is equal 6m plus 0. So 0 is adding to anything, we get the same. So that is it. So a is equal 6m. So a is equal 6m. 6 how you can write? 2 3 ja. So here 2 into 3m. So a number which is multiples of 2, that number is called even integer. So here the 6m we can write as multiples of 2. Therefore the 6m is a even integer. So here a is equal 6m is an even integer. Case 2. So case 1 we can prove that it is a even integer. Next case 2. So if r is equal to 1, so then a is equal 6m plus 1. So even integer means what? A number which is multiples of 2. A number which is divided by 2, the remainder is 0. Odd integer means what? A number which is divided by 2, the remainder is 1. So here the 6 we can write as 2 into 3m plus 1. So that means the number which is divided by 2, the remainder is 1. So therefore a is equal 6m plus 1 is an odd integer. Is an odd integer. Next case 3. Case 3. If r is equal to 2, then a is equal 6m plus 2. So 6m, how you can write? 2 into 3. So 2 into 3 plus 2, how you can write? 2 into 1. So in this 2 what the common? 2. So that is here 2 or 3m plus 1. So a number which is multiples of 2, therefore the number is called even integer. So therefore a is equal 6m plus 2 is an even integer. Even integer. Next, case 4. Case 4. So, if r is equal 3, if remainder is equal 3, then a is equal 6m plus 3. So 6m, how you can write? 2 into 3m plus 3, how you can write? 2 plus 1. So here 2, how you can write? 2 into m, 2 into 3m plus 2 into 1 plus 1. So in this 2, what are the common 2? That is 2 of 3m plus 1 plus 1. So a number which is divided by 2, the remainder is 1. That number is called odd integer. So therefore a is equal 6m plus 3 is an odd integer, odd positive integer. Next, case 4, case 5. So what is the case 5? If remainder is equal 4. If remainder is equal 4. So then a is equal 6q plus 4. Oh, 6m plus 4. So 6, how you can write? 2 3 ja. 4, how you can write? 2 2 ja. So that is a 2 into 3m plus 2 into 2. So in this 2, what the common? 2. 2 is taking outside, what the remaining? 3m plus 2. So therefore a is equal 6m plus 4 is even positive integer. Case 6. If remainder is equal to 5, so then a is equal 6m plus 5. So 6m, how you can write? 2 into 3m. 5 you can write as 4 plus 1. 4, how you can write? 2 2 ja. So 2 into 3m plus 2 into 2 plus 1. So in this 2, what are the common? 2. So that is 2 of 3m plus 2 plus 1. So any number which is divided by 2, the remainder is 1. That number is called odd positive integer. So therefore a is equal 6m plus 5 is an odd positive integer. So therefore hence proved. The integer we can show that even integer and odd integer. Okay, even integer are in the form of 6m, 6m plus 2, 6m plus 4. Odd integer are in the form of 6m plus 1, 6m plus 3, 6m plus 5. Show that one and only one out of n plus 1 and n plus 2 is divisible by 3, where n is any positive integer. Here they given that divisor 3 and integer is n. Here quotient we don't know that. Let us take the quotient is q, remainder is r. So we can get the remainder. How we can get the remainder values? By using Euclid division lemma. So here first, let us take n is any positive integer. So that is divisor is 3 given. Okay, by using Euclid division lemma, Euclid division lemma, Euclid division lemma. So that is here n is equal divisor 3, quotient we don't know that. Let us say the quotient is q plus r. So here the remainder values is condition. The relation between remainder and divisor is 0 less than or equal or less than the divisor. Here the divisor is how much? 3. 0 less than or equal 3. So here what are the values of remainder here? The remainder is equal 0, 1, 2. Remainder values is 0, 1, 2. So here first n is equal 3q plus 0 if r is equal 0. Next n is equal 3q plus 1 if r is equal 1. Next n is equal 3q plus 2 if r is equal 2. Okay, now we can check that the n values 3q plus 0. 0 is adding to anything with the same. So that is here n is equal 3q. Okay, now we can check that first case 1. Case 1. So here if what the Question show that one and only one out of n plus 1 n plus 2 is divisible by 3. Okay, so here case 1, if n is equal 3q, so 3q means 3 into q, that means it is multiples of 3. Multiples is nothing but divisible, so therefore here then n is divisible by 3. Next case 2, if n is equal 3q plus, if n is equal 3q plus 1, okay, yeah, then n plus 1, if n is equal 3q plus 1, it is not divisible by 3. Next then and n is n plus 1, that is equal 3q plus 1 plus 1 is equal 3q plus 2, it is also not divisible by 3. And n plus 2, that is equal 3q plus 1 plus 2, that is equal 3q plus 1 plus 2, 3. So if n is equal 3q plus 1, it is not divisible by 3. Next n plus 1, in the place of n we can take as 3q plus 1 plus 1, that is equal 3q plus 2. It is here in this case is also it is not divisible by 3. It is not divisible by 3. Next n plus 2, that is equal 3q plus 2. n plus 2 is equal 3q plus 3. So that is 3q, that is 3 into q. 3 we can write as 3 into 1. So in this 2 what the common? 3. 3 of q plus 1. Therefore n plus 2 is multiples of 3. Multiples of 3 is nothing but divisible. So therefore n plus 2 is divisible by 3. Is equal 3q plus 2. Here what the meaning here? N is divided by the remainder is 2. So here it is not divisible by 3. It is not divisible by 3. Next and n plus 1, that is equal 3q plus 2, it is n plus 1, that is equal 3q, 2 plus 1, 3. So that is here 3 of q plus 1. So that is here n plus 1 is divisible by 3.
ఒక నిమిషం అది మిస్ అయింది లాస్ట్లో 3q ప్లస్ 1 కాడ మిస్ అయింది అది
3
ఇక్కడ n ప్లస్ 2 3q ప్లస్ 1 చెప్పారు కదా అది మిస్ అయినది మళ్ళీ చెప్పన్నాడు
n plus 2, here n value is how much? 3q plus 1 plus 2, that is equal 3q plus 3. 3q we can write as 3 into q. 3 we can write as 3 into 1. 3 of q plus 1. So n plus 2 is equal multiples of 3. Multiples of 3 is nothing but divisible by 3. Next case 3, n is equal 3q plus 2. Okay, here if n is equal 3q plus 2, it is not divisible by 3. Next n plus 1, that is equal n value is how much? 3q plus 2, that is 3q plus 2 plus 1, that is equal 3q plus 3, that is 3 of q plus 1. So that is therefore n plus 1 is divisible